So, hello everyone. I welcome all of you at GeeksforGeeks learning platform. I'm Avinash, and just let me know in the chat section whether my voice is audible or not, my screen is visible or not. Okay. I would like to know from the chat section whether my voice is audible and my screen is visible or not. Please just let me know. In this section, we have certain things to discuss. Okay. So please just let me know whether my voice is audible and my screen is visible or not. That would be really helpful for me to understand that whether my voice is audible and my screen is visible or not. Anyone from the chat section? Anyone from the chat section? Can you please let me know about this thing? Okay. Okay. Yeah. Hi, Ajay. Can you please, Ajay, confirm that my voice is audible or not? Is it audible? Is it audible? Is it audible? My screen is visible? Yes. Completely. Good. Good. Thank you, Ajay. Thank you. Okay. So basically, I hope you all have understood that the motive of this session is basically that we have to cover the PYQ part. Okay. Now, most of you have the, one thing in your mind that in the data science topic, we don't have any PYQ. So from where we have to come up with the PYQ section. Let me tell you one thing. Calculus and optimization PYQ. I think you all know that the calculus is the subject of a topic of the mathematics, and math is common in all of the GATE syllabus. Okay, whether it's a computer science, whether it's electrical, mechanical, civil, or chemical, aerospace, any of the branch, if you pick, the mathematics will be definitely available as a branch of it. Now, if it is available, then definitely the mathematics section will consist of either and the calculus, then the algebra, okay, then the statistics or probability, right? These are the topics that we basically encounter. We have the questions, okay? If you have gone through the syllabus part, we have to learn about the limit in the data science. We have to learn about the maxima minima, okay? Then the continuity differentiability, the differentiation part, the optimization part, right? These things we have to learn. Specifically, they haven't mentioned about the integration, so we are not going to cover the integration part because they haven't mentioned that part. But the topic they have mentioned so far, we are going to cover that one only, okay? Before proceeding the further things, I would like to give you one thing that will be really helpful. Since this is the Diwali season, okay, so GfG has come up with the thing where you can have a good deal on the live courses, okay, get live courses or get the like self-paced courses or the test series if you are interested in test series. So you just have to apply one coupon code. That is the coupon code name is our the coupon code is basically just a second. The coupon code is basically GfG Diwali. Okay. Once you are applying, all things will be in the capital. Once you are applying, you will be getting the 30% of the discount on each and every GATE related courses. Okay. Whether it's a self-paced or the online or the GATE test series, you can have this. This code is valid till the Diwali. Okay. So the maximum things, if anyone is interested for that, if anyone who is looking for the GATE courses, then they can apply these courses and they can go with it. Okay. So now let's start with the question wise. Okay, if I'm going to see the previous year question paper, so in the previous year question paper I have seen that in the calculus optimization, 1 number question marks has asked for the 2 questions, 2 marks question has asked for the 3. So total number of a question they have asked is 8 marks of a question, but this can be vary because last year they have a less question on the calculus part, more questions on the algebra sections, but this statistics could be vary every time, right? So initially, we are going to do the questions which are based on the first thing is which are based on our previous year. Okay, so this is the question which I'm showing you right now. This is the question of the previous year GATE data science. If anyone has given the examination, I hope you can easily understand that these questions we have got in the last year, 2024 question. This is okay, this year only. The question is saying as for any twice differentiable function f, which is r to r, if the sum x star, which is the element of the r, and f dash x, so they are written as f dash x star, okay, is equal to 0, right? And f double dash x star, okay, and they are written that f double dash x star, which is greater than 0, okay. In that case, the function f is necessarily have this. Now, every time Whenever we are looking for the gate level of a question, sometimes they give you a random data. Once I'm looking at this data, I can easily see that the following this data not too much useful. Okay, for here not too much useful. You just have to understand one thing: when they have given the function, when it is differentiating of x star, it is coming as a 0. Once we are differentiating anything and it is coming as 0, it means that the following thing are exactly constant, because the differentiation of a constant will only give you the 0. It means that, can I say that this is the constant data? Okay, this x star is nothing but the constant data. First thing that you need to understand about this. Now, if you have understood this, the question they are saying is the function will be necessarily have what is local minima, local maxima, global minima, global maxima, right? So from here, I would like to give you a glimpse of it. What is the local maxima and minima? I hope you all know that once we have to find out the local maxima minima, we have a differentiability test. Okay, we have a single differentiation, double differentiable. This is the test that we have gone through. So simply what we have to do, first we will find out the f dash x. Okay, then we will find out the f double dash x. If f double dash x is greater than 0, okay, this is the case of a local minima. And if f double dash x is a less than 0, okay, this is the case of a local maxima. Simple case, you need to just remember that point. On the basis of this point, if you remember just this theory that you have to remember, now can you say that what will be the answer for this question? Simply they have mentioned that f double dash star is greater than 0. Once it is greater than 0, it means that the previous slide, now you have to remember greater than 0. Okay, once it is greater than 0, the case will be occurring as a local minima. Okay, so in that case we have a local minima case. It was just a definition part, it was not even a question. They are just create a question something like that. You need to understand, okay, like, oh, this is a very difficult question, they are asking something, the real number relation and the x star thing, but it was just a definition part. Okay, anyone has any doubt? Anyone has any doubt? Please just let me know if you have any doubt. Okay, because I have to the chat is going on right in front of me. Anyone, if anyone has any doubt, please just let me know. Okay, so next, see, the question is saying that f is the function. It is a value function of given as fx is equal to 1 upon 1 plus e to the power minus x. The value of for differentiate the value of a derivative of f at x, where fx is equal to 0.4. Okay, now see this thing. We have given as a fx is equal to given as a 0.4. Okay, and we have to find out the derivative of f. We have to find out the f dash, right? The question, once you're looking at this, first I will give you the hint about it. Okay, just let me see, there is a chat. Sir, what is the condition for a global maximum minima? I have already mentioned, Ajay. Okay, I have already mentioned that part. You just have to see this page. Okay, you can see this page, local maxima, local minima. Okay, and just for this, okay, you can you have a guidance for the global maxima, global minima too. Don't worry. Just the important thing also we have to cover over here. Like in the first question, we have just understand about the local maxima, local minima. Understand that part. Go to your books in your study material and focus on. We have to cover at least this part. Okay, whatever the topic in the next 2 days also, we have a 3 days about the calculus. In the upcoming 3 days, whatever the topic I will mention, just focus on that. Simple, and that's it, right? If you're looking at this question, the function is given as this. Okay, now most of the people will think, okay, how this question could be done? The question was very easy. Okay, simply what they have given this data. Suppose if I'm going to differentiate that part, okay, for a function we have to differentiate. So what will be the value is exactly equal to, this will be 1 upon 1 plus, can I write like this, 1 by e to the power x? This is nothing but 1 upon e to the power x, okay, e to the power x plus 1 and divided by e to the power x. This e to the power x will come upside, right? So the function we have created. Okay, now we just have to differentiate it part, and we can differentiate it also. Okay, the differentiation part is not difficult, but the important thing is they have given the value, function value is equal to 0.4, but we have to find this data. How we can solve? Let me give you the very short example of it. You just put value over is this is equal to 0.4. Okay, if I'm putting 0.4, what will be happen? 0.4 is equal to 1 upon 1 plus e to the power minus x. Okay. Can I do one thing? I'm doing the cross multiplication. So this value will be 1 plus e to the power minus x. Can I write like this? 1 upon 0.4. Okay. So from here, can I get the value of e to the power minus x? So e to the power minus x will be, this 1 will be in the minus. So can I write like this? 10 by 4, 5 by 2. Okay. So 5 by 2 minus 1. I hope from so far you have got this point. Okay. So e to the power minus x value will come is equal to what? 5 minus 2, that is 3 by 2 is equal to 1.5. I hope you have got this. We have received the value of e to the power minus x, that is equal to is equal to 1.5. Now simply you just have to differentiate the data. So now I'm gonna differentiate that part. If I'm differentiating, from here I have got the value of e to the power minus x is equal to 0.5. And after once I'm differentiating that part, I'm getting e to the power minus x, e to the power minus x divided by 1 plus e to the power minus x whole square. On the value of e to the power minus, I will place 1.5. Okay, so 1.5 divided by, this will be 2.5 whole square. Okay, so 2.5 into 2.5. If I just solve this part, you will get the answer. The answer is equal to 0.24 because we have to give the decimal and after 2 points. So the answer will be 0.24. Okay, simple. These two questions I have shown you. This was the GATE data science of this year GATE questions, and which are based on the optimization and calculus. And I hope maximum it will take maximum 4 to 5 minutes to solve these two questions, and you can easily got 6 marks easily. So always don't fall the trap if the GATE is giving you a certain things. Okay, they want you to give fall in the trap, but the questions are not as much difficult. Next. The function fx is given as fx is equal to max x and xq when x is the element of a R. R is the set of all real number, the set of all point where fx is not differentiable. I'm going to give you the two methods. Okay, the first method is easily that if the function is differentiable, sorry, if the function is a continuous, then it should be the differentiable, and we can go with that formula. But I'm not going to use that part. I'm going to use the graph for it. Okay, see this thing. If you're looking very closely, may I know that the function fx graph will be something like this. It will be crossing the origin, right? And the next graph of xq will be what? It will be something like this. If the graph is following, it will go like this. Sorry, my bad. It will be something like this and something like that. It will go because it's a cubic graph. Okay. So the graph will be something like this. It will go. I have made a graph actually handily. So this is the graph that it will go. Okay. So it just like the first graph I'm receiving something like this. Okay. If the origin is this. Okay. And the graph of a xq is leading to the point of a something like this. Okay. This is the point. Now see very carefully. I'm coming to the our back point. This is the graph that actually have made. Now what they are asking for, they are asking for the function where the function is not differentiable. So I'm just picking the maximum point. Okay, if I'm talking about the maximum point, okay, see this point. I think this point, this point, this point, this point. From here there is a break point. Then this is the maximum we'll get. Okay, then there is a breaking point, and that will be the maximum. Then there will be break, and that will be the maximum. I'm just giving you the image wise. Okay, the explanation which is given by the on the basis of a graph. I hope you remember this point is a 0, and this point that will be 1 comma 1, and this point minus 1 comma minus 1. Okay, so now see here, can you do me a favor, just see the graph very carefully. The graph is just breaking 1 over here, the graph is breaking 1 over here, and the graph is breaking 1 over here. It means if I am looking very closely, I can see here there are two tangents can be drawn on the red points. Okay, so just if the two tangents can be drawn on the red points, it means that the points are -1, 0, and this point is 1. So minus 1, 1, sorry, minus 1, 0 and 1. This will be the points where the function will be not differentiable because we are getting the radical points. Okay, here the tangents can be drawn multiple. This is one approach. But what if you are not able to understand, what if you are not remembering the graph? Then what you will do is simply, if the graph is written like this, okay, then you just have to differentiate. I have differentiated the graph, the limits that they are already given. Once I'm differentiating, then what is the things that you need to understand? Okay, 0, 0 minus and 0 plus. This is how we do. The adjacent neighbor we check. Okay, so if x is equal to minus 1, we will check. Then fx is equal to minus 1, just right hand side, minus 1, just left hand side. And if we are checking that if LHS is not equal to RHS, it means that the point is not differentiable and the point is coming as a minus 1, 0 and 1. Regular method is this. But the classic method, that if anyone has known about the graphical things, then they can go and they can approach that method also. Okay. Next. Suppose fx is defined as the fx is defined and the minimum value of fx is equal to 0 to 2. See, this is the closed bracket. Okay, fx is equal to 25 upon 8x when x is less than or equal to 3 by 2 and x plus 1 by x otherwise. Okay, we have to check this one. Okay, first I'm going to find out fx value. Fx value is equal to what? 25 upon 8x. Okay, so I can write like this: 25 by 8 x to the power minus 1. Okay, so f dash x is equal to what? It will be minus 25 by 8 into x to the power minus 2. Okay, just looking at the graph, can anyone confirm that this will be definitely a decreasing function? Because initially it has mentioned that the minus has already came from the function. Just in front of a function, the minus has came. It means that the function is equal to minus 25 by 8 x to the power minus 2. The function will be definitely going to be the decreasing function. Okay, check one more time. Differentiate one more time it is. Okay, so f double dash x is equal to what? That will be 25 by x, 25 by 8 into 2 into x to the power minus 3. Okay, so that will be 50 by 8 and x to the power minus 3. So 50 by 8, okay, this seems a positive function. Once it is coming as a positive function, now you have to check at this. Okay, the once it is coming as a positive function, that is equal to 50 by 8 x to the power 3, 1 upon x to the power 3. This seems like a positive function. So now we can check for x is equal to this point. Okay, so I am putting that x is equal to 3 by 2 over in this function. Once I'm putting x is equal to 3 by 2, so that will be 25 by 8 into 3 by 2. This will be 50 by 24. Okay, so that will be 4. That is equal to 25 by 12. One thing we have got, 25 by 12, 1 point we have received. The same operation we have to do with the x plus 1 by x2. Okay, the question, don't always fall for the question like, okay, this question has a specific method to do. Don't always fall for specific methods. Okay, if you are looking at the question, if your basics are clear, you can easily go for it. See, there are two methods I have solved this part. Okay, the one method is simply like this. From the function, once I'm differentiating, the interval is decreasing. Okay, again, then once I'm again differentiating this function, then the function is increasing. Since the function is a decreasing and increasing, it means there will be a middle point, that is x is equal to 3 by 2. Once I'm checking the 3 by 2, I'm getting the value of that 25 by 12, that is equal to 2 is to 1 by 12. That is the answer that we are exactly getting. Eventually, I haven't used much of the data that x plus 1 by x, but still, if you want to check now, then I'm giving you the hint for it. Fx is equal to x plus 1 by x. Okay, I hope this is the graph. This is the function they have given, x plus 1 by x. Say this one. If I'm putting f dash x, that will be 1 minus 1 upon x square. Okay, x to the power minus 1, so that will be 1 minus 1 upon x square. And f double dash x is equal to what? That will be 2 upon x cube. Okay, this is the graph we have received. So it means that at x is equal to 2, okay, if I'm putting x is equal to 2, the function is coming as a positive. So at x is equal to 2, I'm going to check. So 2 plus 1 by 2, that is equal to 5 by 2. Okay, if we are going to check, we have to go for the minimum value. The first function we are getting as a 25 by 12. The second function is getting as a 5 by 2. Which one is coming as a minimum? 25 by 12. And the in short, the answer will be this. Okay. 24, 2 is to 1 by 12. That will be the answer of yours. I hope you got this point. Anyone has any doubt? These all are GATE previous year question paper, guys. I am not picking any questions which are not from the GATE. Okay. All the questions that I have fetched, these are from the previous year question paper. Next. See this question, limit extending to a 3, x4 minus 81, 2x square minus 5x minus 3. Simply, if I'm putting x is equal to 3, that part will be 0 and that part will be also 0. So this is the 0 by 0 case. It means that we have to apply for what? Whenever the 0 by 0 case, infinity by infinity case come, then we have to go for the L'Hospital rule, right? Differentiate above data. 4x cube divided by 4x minus 5. Okay, now if I'm putting that over here, what will be the answer? Okay, simple. Now once you have differentiate that part, after differentiating you just have to put the data. So x is equal to 3 will be 4 into 27 divided by, that will be 12. Okay, so I think x is equal to 3, so 12 minus 5 is equal to 7. Okay, so that will be equal to 108 divided by 7. The answer is equal to 108 divided by 7. Tell me, how much time did you exactly took to solve this question? Simply, GATE CSE 2019 question. Okay, if this question is coming by the 2 marks, then you have to just make sure that how you can do this question. L'Hospital rule, limit. Okay, from the limit L'Hospital rule, from the maxima minima. Okay, then the continuity differentiability. So far we have discussed 3 to 4 questions, and I hope that none of the question seems like this much difficult. Okay, simple. This one is also, once I'm putting the sine x minus 4 upon x minus 4, once I'm putting x is equal to 4, this case will be 0 by 0. Okay, the first case is just apply the L'Hospital rule. Okay, what will happen in the above will be cos x minus 4, and in denominator it will be 1. Once I'm putting x is equal to 4, cos 0, the value will come as a 1. Answer will be 1. Okay, one way to solve this one is like this, and another one is the sine x minus 4 upon x minus 4. Sine hyperbolic function can also be described, and so the limit function for this, the sine hyperbolic function, is directly answer is equal to 1. So if you remember the formula, you can easily see this data and can find the answer of it, that is equal to 1 directly. You don't have to just go and check all of this. Okay, see this, if the function polynomial gx is equal to f dash x is the derivative, if the degree of fx and f of minus x is 10, then the degree of a g of x minus g of minus x is equal to what? See, the language could be a bit of a thing that you need to worry about, but I'm going to tell you that, the question was very easy. What they are saying is fx is equal to simple like this. They are saying now the degree of this is equal to 10. Okay, so what will be the value of fx plus f of minus x? Okay, so that will be x to the power 10. Okay, and what about the f of minus x is minus of x to the power 10. So this will be x to the power 10 plus x to the power 10. That will be equal to 2x to the power 10. Right? One thing is confirmed. Now they are saying is we have to find out the gx minus the g of minus x, and gx is equal to what? F of x. So if I'm differentiating that time, so that will be 10x to the power 9. That is the value of a gx. I'm putting the data 10x to the power 9 minus, okay, this will be equal to what? G of a minus x. Okay, so minus of a g of minus x is equal to what? 10 of minus x to the power 9. Okay, that will be equal to 10x to the power 9, and this minus minus will go plus 10x to the power 9. This will give you the 20x to the power 9. Okay, so now can you tell me what is the value, what is the degree of it? The degree is coming as simply 9. This was the actual question of yours. Again, I'm telling guys, the questions are not difficult. We have a one question, direct formula. Okay, Okay. So we have this simple questions. Either you can go with the direct formula, or if you want to go with the normal method, we have both of it. Okay. Next question. Limit x tending to infinity 1 plus x square e to the power minus x. Again, guys, simply the question is 1 plus x square upon e to the power x. Okay. Simply, if I'm putting x to the power limit tending to infinity, this will be infinity by infinity, not working, right? Apply L'Hospital rule, that will work. Differentiate one side, so denominator and numerator, that will be this. Still, I'm putting x is equal to infinity, not working because it will be again coming the infinity by infinity. So, as per the L'Hospital rule, we have to differentiate again. So that will be 2e to the power x. Now, numerator is free from x, but still denominator isn't free for x. So don't worry. So 2 upon e to the power infinity, e to the power x, that we can write 2 upon e to the power infinite is equal to 2 by 0. Sorry, 2 by infinite. Okay, which is equal to 2 by infinite is equal to what? 2 1 by 0, which is equal to 0. Simple. So this was a question, okay, and this was the 2 marks of a question. GATE Computer Science 2015 paper. Answer is equal to what? 0. Okay. See this question. Which of the following function is continuous at x is equal to 3? So for the continuity and differentiability, I hope if you remember that, if we have to check any graph is continuous or not, how we are going to check that part? Suppose we have to check over here. So we pick this point, x is equal to k. Now just before, this will be k minus and this will be k minus, and just after this will be k plus. So if the function who is continuous at x is equal to k, fine. If the function who is continuous at x is equal to minus k, still good. If the function who is x is equal to plus k, and if it is still coming as a continuous, it means our case is properly defined. This is how we check. So we are going to check the same thing over here. Check over here 2 when x is equal to 3. Fine. Okay. One, we are putting x is equal to 3 plus. Okay. So value will be 3 minus 1, which is equal to again 2. Okay. For the right hand side, it is coming as a true. For x is equal to 3 minus, what will happen? 3 plus 3 by 2, which is again coming as a 2. 3 plus 3 by 2, which is 2. It means we are checking then this function is coming as a continuous. Okay. Followingly, if you are checking over here now, like for 3, it is 4. Okay. But once you are checking not is equal to 3, it means just 3 minus. Okay. 8 minus 3 is equal to 5. So one is coming 4, the second one is coming 5. It means it is not matching. Same you can apply over here also. So the function will be easily can be solved. This much of a easy questions we are getting in the GATE examination. Okay, just you have to do the practice. That's why I always mention in my sessions, just do the PYQ, guys. Okay, in these 3 days I will try to cover the 10 years of a question papers. Okay, 10 year of a different questions I am picking up and I'm gonna solve over here, right? But you have to do one more thing. The questions that I'm solving here and the concept that is exactly using over here, you just have to go and check the concept whether it is you understand this concept or not. This is really important part. Okay, next, for the following function of this suppose fx is equal to mod x. So fx is a continuous for all the real value, fx is differentiable for the all value. Okay, I'm going to give you the 2 explanation for that. The first one is the graphical approach. Okay, I hope if you all remember, okay, the modulus of x graph. Now, the function is a continuous, okay, but over here, okay, do you really think this is the differentiable? I don't think so. Okay, looking the graph character, it is a break-even point. Okay, here the graph is exactly breaking. So definitely P is coming as a true and Q is coming as a false. But again, this is the graphical approach. I'm gonna solve this question one more explanation way. That is called as our the another approach. So simply what we have to do, basically LHS is equal to RHS. Okay, and the modulus function, once I'm putting 2, outcome is coming as a 2. Great. If I'm putting 0, the outcome is coming as a 0, again great. But once I'm putting input as a -2, the output is coming as a 2. Okay, it means that that is not truly acceptable because the LHS is not is equal to coming as a RHS, right? In that case, what we have looking at this, fx is equal to mod x, the LHS isn't coming as a RHS, right? That's why the function, this one is coming as a p is true, but q is coming as a false. Okay, I hope you understand this question. Next, same question explanation I have given. Okay, if anyone has, because I use a 2 to 3 methods to explain this. The first, because see, I believe the graphical method is much more easier, but still if someone want to go for a plus minus, they can also go. But if someone has learned this part, okay, 0 0 plus h 0 minus s, they can use also. The answer will be not gonna change, answer will be definitely the same. Okay, next, what is the value of a limit n tending to infinity 1 minus 1 upon n to the power n? Okay. Now see here, the function is given as a limit n tending to infinity 1 minus 1 upon n to the power 2 to the power n. I'm going to write this function as like this. Y is equal to limit n tending to infinite 1 minus 1 upon n to the power 2 to the power n. I'm going to use the log both sides because it will make our expression as a linear. Okay? So let's check. Log y is equal to limit n tending to infinite to n. Okay, that will be log 1 upon 1 minus n. I hope this is so far there is no issue in that. Can I apply infinite value over here? Okay, I'm not sure because the value will be tending to the infinity. So the first thing, once you have done so far, okay, now after that you have to just do one thing. This 2n part, if you're looking at this now, instead of that 2n part, can I write like this 1 by 2n? I'm replacing this 2n like this. So now I'm just erasing this 2n part. Okay. So can I write like this, limit n tending to infinity log 1 minus 1 over n divided by 1 over 2 to the power n. Simply I have just done the bit of a manipulation and rewriting part. Once we have done that part, okay, just simply just have, now we have to apply the L'Hospital rule, okay, because now we can apply log 1 upon log 1 minus 1 by n. Okay, this will be what, 1 upon 1 minus 1 by n into we have to differentiate 1 minus 1 by n. Okay, if we are differentiating that, that will be 1 by n square divided by 2 to the power minus n. Okay, that is 1 upon 2 to the power n. Basically it is nothing but this is our 2 to the power n. Okay, so 1 upon this, if I'm going to solve this one, so 2 to the power minus n exactly. Okay, so if I'm going to solve, that will be 2 upon 2n square. I'm just using a bit of a shortcut. Okay, I have done over here, that's why I just use that part. Once you are going through, you can see that the n square part having the cancellation thing, minus 1 2. Okay, that will got cancel, and after that log y, okay, log y is just simply is equal to -2. The calculation part I am leaving up to you guys because this you can do easily, right? So y is equal to what? E to the power, y is equal to e to the power -2. The question was same, solution was not difficult, only you have to do one thing, apply the L'Hospital rule. But the question was not in the mode of a L'Hospital rule. So what we have done, we have taken the log. After that, we create like a log of function of a p by q, because to apply the L'Hospital rule, then we have differentiate numerator, we have differentiate denominator. Whilst differentiating, the function has converted, okay, and then we have got the answer. Okay, see this one. The point on the curve is said to be extreme if the local maximum, local minimum, or the local maximum. Okay, the number of distant extrema for the curve. Okay, we have to find out the distant extrema. Someone has asked about the cases, so now here we will see about the extrema case. The local minima maxima I have mentioned, extrema case I am going to mention. In the upcoming questions, you will see that the local maxima questions will also going to discuss. So don't worry about it. What we have to do, the first thing is differentiate. Okay, that will be 12x cube minus 48 x square plus 48 x. I think this one is the thing. Double differentiate that one too. It will be 36 x square minus, this will be 96x plus 48. Put double differentiation is equal to 0, that will be there will be two roots that will come from here. Okay, so if I'm putting the double differentiation is equal to 0, I hope you are getting this. The single differentiation we have done, okay, once we are doing, we are getting two roots. Okay, after that, once we are doing the double differentiation, once we are putting the double differentiation section over here, let me see if any chat is coming. Okay, there is no chat. So if we are putting the double differentiation over here, we have a 2 point 0 comma 2. So I'm going to check about the 0 and 2 for the both of the point at fx is f double dash x. Okay, at x is equal to 0, I'm going 48. If you can look over here, at x is equal to 0, I'm getting 48, which is greater than 0. Once it is greater than 0, this is the case of a local minima. That's fine. Now we know this point. Now once I'm putting x is equal to 0, okay, that is good. But once I'm putting x is equal to 2 over here, I'm getting 0 value. You can put over here, this will be 4 into 36 plus 48, and this will be 96 into 4, 96 into 2. This will be giving you the 0 value. Once I'm applying this, the function is coming as a double differentiation is coming as a 0, which is not a double derivative test. It means that we have to focus on the first derivative test because second derivative test has got failed. Now, if I'm applying the first derivative test, see this f dash of a, we have to got at a, because we have checked for the 2, okay, so we will got as a fx is equal to, at 1 we will check because the adjacent of a 2 will be 1 and 3. So I'm going to check on 1, I'm going to check on 3. If I'm checking on both numbers, I'm getting that a 1 is fx at 1 is equal to coming as a 12 positive number, and this one is also coming as a positive number. So those number are coming as a positive, it means f dash x isn't changing once we are putting the left right of a 2. It means the only extrema that we are getting is equal to x is equal to 0. Again, the point to be noticed over here, what happened once our the second derivative test has got failed. Okay, in that case we need to proceed with the first derivative test. We need to check our LHS is the adjacent over 0 plus and 0 minus term. If you have checked that part, then you can proceed it. Don't remember the questions, okay, remember the steps that we are using to solve this kind of a question. After, I'm telling you guys one more thing. The question number 1, question number 4, and then question number 7, okay, they have used almost the same concept, just they have done one thing, that is once you are applying this formula, the concept are using same 0 plus 0 minus, that's it. Okay, but just you have to remember that thing during the examination. Okay, if I'm using that part now, like you need to remember that how this kind of a question can be solved. So x minus sin x upon x plus cos x, right? If you are just applying x is equal to infinity, that will be infinity by infinity case, not interested. If I am doing the differentiation, okay, one time, that will be 1 minus cos x divided by 1 minus sin x. Okay, still because the x and x part will come at infinity, again infinity by infinity. Even the double differentiation will also not help because still there will be sine and there will be cos, so the x term isn't removing. So how we can solve this kind of a question? Once you are looking at this now, though, you can do one thing. Take x common and from the both side. Okay, so like if I'm taking x common, can I write like this, x upon sine x upon x, and this will be x upon 1 plus cos x upon x. Okay, this x to x cancel, and here it will be limit x tending to infinite. Okay, now precisely I don't know how many of you have remember or not, but the limit of sin x by x when x is infinity is equal to 1. and the limit extending to infinity cos x by x is also coming as a 1. This is the formula thing, but still if you're not remember, then you have to again go for the L'Hospital rule and you can find the answer. But in general, you have to just remember that part. Okay, this part is coming as a 1 by 1. Okay, so simply if you remember that thing, that is totally fine, because then this part is equal to coming as our is 0. Limit this part is coming as part is equal to 0. So 1 by 1, that is equal to 1. The answer will be coming as a 1. So limit x tending to infinity sin x upon x is equal to 0. Limit x tending to infinity cos x upon x is equal to 0. Remember the formula is your question. Not remember the formula, solve the question, waste your time in the examination. Okay. Next. There is somewhere you will see that this question has solved with the help of actually the theorem that I have applied over here is the squeeze theorem. Yet it is not required. But some of the students mentioned that, okay, so far I have learned to solve this kind of a question from the squeeze theorem. So squeeze theorem can be solved with the help of this. This is our squeeze theorem, and you can solve by this also. Okay. Next. Fx is equal to sin x in the interval of x is equal to pi by 4 to 7 pi by 4. The number and the location of the local minima of this function will be is equal to what? Anyone can give me any idea how this question can be solved? Anyone? Anyone? Can anyone can give me any idea? Anyone? Anyone? Okay. See this. I'm taking one interval over here. Okay. Let's check the pi by 2 and 3 pi by 2. If I'm taking pi by 2, the value is coming as equal to what? At pi by 2, the value is coming as a 1 positive, right? And at 3 pi by 2, the value is coming like same. So for this question, see this. First function is given as a sin x. Okay, so I'm going to differentiate that part. Okay, put x is, what is the value is coming as a cos x value. Okay, then cos x is equal to 0. This give you the roots of is equal to what? Pi by 2 and 3 pi by 2, which is lying on this part. Okay, pi by 4 and 7 pi by 4. I think so far you have understood that thing. Just simple thing, differentiate, putting is equal to 0. Okay, and then once it is coming as a 0, find the value, check whether it is lying on the same interval or not. Now again, redifferentiate. Once I'm redifferentiating, the value is coming as a pi by 2, but it is less than 0. Okay, it means once it is less than, the value is coming as a less than 0, the case will be local maxima. Questions has discussed this kind of a thing. Okay, but at 3 pi by 2, the value is coming as greater than 0. This will be the local minima case. Okay, less than 0 local maxima, greater than 0 local minima. Remember the fact, really easy part. Okay, it means that at pi by 2 we are getting the local maxima and the graph is completely increasing. At pi by 4 we are getting the local minima. It means the local minima will be pi by 4 and 3 pi by 2. Always see the thing are now like the concept, they are not going to change. The concept is specific. The concept having the same kind of a thing we have to do as a concept wise. You don't have to just go again and again and again to learn about the conceptual part. The concept, the theory, the formula, they all are having the same thing, right? What you have to do the maximum number of a question, that could be done in the practice format. If you are doing the practice, that would be give you the confidence to apply the conceptual part. So far, any question I think once I have solved this part, I can guarantee you about this, like all of you can give me the thumbs up, like, okay, I have sometimes we have learned this formula. Okay, we have gone through this kind of a concept. So I hope you can got this thing, right? See this one, the limit value x to the power 7 minus 2x5 plus 1 x cube minus 3x square plus 2. Okay, now the question is again, if I'm putting 1, okay, putting 1 0 by 0 case, right? Simply apply the L'Hospital rule, differentiate both sides. Okay, so if I'm applying just both sides, that will be 7x to the power 6 minus 10x to the power 4 divided by 2x square minus 6x. Okay, can I do one more thing? Okay, can I take the common part? I can isolate the common part also. So 7 3, even if you don't want to take common, still this question has solved actually. So this will be 7 minus 10 divided by 2 minus 6. That will be equal to minus 3 divided by minus 4. Okay. So if you're looking at this 2 minus 4, okay, 2 minus 6 minus 4. Okay, just a second. I think I have done somewhere mistake. 7x6 minus 10x to the power 4 upon, sorry, this will be 3x square. I'm so sorry. That will be 3x square minus 6x. Okay, so that will be 7 minus 10 upon 3 minus 6. Okay, so it is equal to minus 3 upon, I'm so sorry, I have done one calculation error over here. 3, that is equal to 1. Okay, so the answer is coming as a 1 over here. Next, fx is equal to x sine x. That is satisfy the following equation: f double dash x plus fx plus t cos x. Let's see this thing. Fx is f double fx f dash x is equal to what? X cos x plus sine x. I think I can write like this. And f double dash x is equal to what? That will be minus of x sine x plus cos x plus cos x. Okay, I think I can so f double dash x plus, I'm gonna add this term over here plus t cos x. So far, okay, so just I'm gonna accelerate a bit of it. Okay, see, so this is the f double dash x and this is the f dash x. I'm just adding, so x into minus sine x plus cos x plus cos x plus x of sine x plus t cos x. Okay, now can you confirm that part? One thing that will got cancelled. So 2 cos x plus t cos x is equal to 0. Can I take cos x as a common? 2 plus t is equal to 0. If you're looking at the question part, they are asking for the value of a t. Okay, since either this will be 0 or that will be 0. So I'm using as a t plus 2 is equal to 0. It means t is equal to minus 2. So the answer is coming as a t is equal to minus 2. Please guys, just understand that part. The thing that we are doing right now, that will definitely gonna pace up you, okay, in the examination, because the thing that we are doing right now, this is the creamy part actually. Okay, we have just create the questions which are from the last 10 year. Even I'm not focusing only on the 10 year. I think 15 year or 17 year questions, which whatever I can fetch. Okay, I'm just fetching that part. If we are just looking at these questions, some questions from the 2007 to 2024, these all questions that we are coming over here, coming and using that part. Okay, I'm solving these all questions. So this is actually what we are doing over here. Last 15 to 20 year question paper, I'm just putting in front of you. Now this is one thing I'm going to make sure that if the limit question is coming, I'm showing you all kind of a question. Okay, you will definitely gonna solve this kind of a question. For example, if you're seeing this part, ln x square plus 1 and cos x. So if you generally apply, you will see this is 0 by 0 case. Okay, but we don't have to. We just have to bit of a simplify that. How we are going to simplify? Can I write like this? Ln x square plus 1 plus ln cos x divided by x square divided by x square. Just we have done one simplification. Okay, because I can use that the multiplication property, and once the log multiply, we can do as the addition. So we have done one thing, right? After that, we just have to apply the simple formula. Okay, so in that case, once you have applied that part, now the formula will be coming like this. Okay, now it is done. So far we have completed. Okay, so far we have completed. Now ln of x square plus 1 upon x square. Then again, I hope if you remember, I can take x square common from numerator and denominator. Putting x square common, so this will be 1 plus 1 upon x square divided by x square. That will be got cancelled. Okay, so 1 upon 1 plus 1 upon 1 plus x square. Okay, so this will be got cancelled. Once you are putting the value will be still coming as a 1. So one data is solved. Second data we have to move on. See this. Just you have to do nothing. This is what you have received so far. Okay, this is what you have received so far. putting x square is equal to y, suppose. So this will be limit x tending to 0, ln y plus 1 divided by y. Okay, and if instead of a y, instead of x, we can put as a y, because the function, if it is differentiable, if it is gonna if it is valid for x is x tending to 0, the same thing will be valid for the y is equal to 0 too. Now if you are just solve this part, you will get the value. Same thing, either you can use this way or you can use that way. The both way it will be coming as the same. Now the second limit is this. Okay, the second limit, again, we are solving this part. If we are looking at this, this is coming as a L'Hospital rule. Apply the differentiation part. Once you're differentiating, I'm just leaving this part up to you guys. So once you are differentiating that part, you are getting is equal to minus 1 by 2. The first value is coming as a 1. The second value is coming as a 1 by 2. So the answer will be 1 by 2. See, I'm not intended to come over here to solve the questions which is important, like a maximum number of questions we are solving, or the all the questions I have to do the full solution. Now my main motive is I want to show you the maximum kind of a questions or the type of a questions they have asked so far in the GATE examination. That is really important. Okay, for the limit. Okay, suppose for the limit section, for the limit, okay, continuity and differentiability, okay, maxima and minima, okay, these mostly I have focused on these topic. Okay, almost we have done 20 questions almost. Okay, if I have done 20 questions, so this is not the 20 questions I have done. I have shown you the 20 different kind of a question which has asked from 2007 to 2024. Okay, again I'm making a sure thing that I again come up with the thing like I'm definitely I have left something question, but that gonna cover tomorrow. Okay, so maximum, okay, I want you the maximum participations over here. Okay, and if you don't have a time, you can watch this lecture after the it will be recorded format. Okay, so you can watch this, but once you are in the session, we can have one-on-one conversation. Suppose if you are stuck at something and you want me to discuss any specific conceptual part, okay, sir, I just need to discuss this concept, so I'm here to solve that part also. Okay, like this is the one-on-one conversation. This is completely free of it. Okay, you just have to be available, ask your queries. I'm here to resolve that part. If you want to discuss something as a theoretical part, I'm also going to discuss that thing. So anything, if you feel like, no, I want a specific assistant on this, so I will be here. I'm here. I'm going to give you about this. We have a very less amount of time. Festive season is also over here, so make sure that the question that we are doing here, the question will be definitely important with the help of examination perspective. Okay, if you have any doubt, anything to discuss, please ask. Otherwise, this session is good to end. Tomorrow we will have a same timing. Okay, 5 to 6 we will have this calculus section. I will come up with them because mostly questions I have discussed for the computer science. Right, tomorrow I will be focusing on the electrical, mechanical, civil, and chemical questions. Okay, and they have a lot of questions. We will have an enormous amount of different categories. So what I will do is I'm gonna open the slide. Okay, I'm gonna give you the hint about it. I'm gonna tell you which concept that you have to focus, and that's it. Okay, solution. See now, solution is available. You just I have shown you all the solution. You just have to stop the, suppose if you are on the stop video. Okay, I have given the different kind of a method also, so you just have to go like this. Okay, so this is all for today, guys. Thank you so much for being in the session. See you guys on the tomorrow session. Okay, this is all for today. Thank you.